Hi folks, welcome back to 7.3. We're going to finish off this section talking about unit vectors, okay? So a unit vector is a vector that has a magnitude or length of 1. And there are two special unit vectors that are worth knowing. And so the first one of these is I, or I hat. So I hat or I bar or just I, but not the imaginary I, is the special unit vector that is only horizontal. So 1, 0. It only goes sideways, it doesn't go up and down. The second special unit vector we can call j hat or j bar or just j. And that one is, you guessed it, the vertical unit vector. So 0 for x and 1 for the y. And so we use these to represent horizontal and vertical in yet a different way. And this allows us to write vectors as a linear combination. So what I mean by that is if you have vector A, and you know that it breaks down into a sub 1 and a sub 2, you could also write that as a sub 1 I plus a sub 2 j. All right? And so let's take a look at it as an example and see what I mean by that. So I have two vectors here. I have vector A and I have vector B, and I want us to find the resultant of A minus 3B. So let's take a look at that. So A is going to be 5I plus j minus 3 times 4I minus 7j. And let's see what that gives us. Well, I'm going to distribute this 3. So I will end up with 5I plus j minus 12I plus 21j. And now all I need to do is combine my like terms. So 5I minus 12I is negative 7I. And then 1j plus 21j gives me 22j. And this is my linear combination of A minus 3B. All right, so it's very similar to the addition and subtraction we did in the beginning and the scalar multiplication. We're just using letters like I and J to represent the horizontal and vertical components. All right, so to find a unit vector for a given vector, we can use the following formula. Okay, so sometimes we're asked to find the unit vector. So we're given a vector, A, and if we do A divided by the magnitude of A, we will get the unit vector. So the unit vector is important because it's in the same direction as your original vector, but it has a magnitude of 1. So it's like the same vector, but shorter, or could be longer, all right? But it always has a magnitude of 1. Kind of like how a unit circle always has a radius of 1, that unit vector always has a magnitude of 1. So let's take a look at two examples. So example 9 here. If A equals 5, negative 4, find the unit vector for A. So let's start off with a diagram and see what we're looking at. So A is going to start at the origin. I'm going to go to the right 5, and then I'm going to go down 4, and I'm going to connect those, and I'm going to have it point in the correct direction, and that is my vector A. Now this vector is much longer than 1. So what we want to do is we want to come up with a unit vector that is going to be right on the same line, but it's only going to have a length of 1. All right, so we want to shrink it down so it has a length of 1. So let's take a look at our formula. So U equals A over the magnitude of A. So A is 5, negative 4. And the magnitude of A is the square root of 5 squared plus negative 4 squared, because I'm using that Pythagorean theorem. So this is like my A squared, this is like my B squared, and then I square root it to find the hypotenuse. So if I simplify this, I'll get 5 comma negative 4, and then on the bottom, I'll have 25 plus 16, which is square root of 41. All right. And we're just going to do one last step to get to our unit vector. We're going to sort of split this into the two different components. So one component, the horizontal one, is 5 over root 41. And the second component is negative 4 over root 41. And if you turn those into decimals, it'll tell you exactly how far across and down you need to draw that unit vector. So it's still in the same direction, but it only has a length of 1. All right. So that's a pretty classic case example, and we're going to take a look at one more case which is more applied to kind of get us to understand why it might be important to write things in the horizontal and vertical component form. Okay? So, example number 10. The bicep muscles in supporting the forearm and a weight held in the hand exerts a force of 20 pounds. As shown in the figure, the muscles make an angle of 108 degrees with the forearm. Find the horizontal and vertical components of this vector. All right? So we're going to go ahead and find that horizontal and vertical component. And we're going to do that by figuring out what our I is and what our J is. Okay, so we have this diagram. Sorry about that. We have this diagram, and we're going to go ahead and figure out how to break this up into the horizontal and vertical components. So we've got 108, and we want to figure out 108 with 20 pounds. All right, so this part right here is a length of 20, and I want to break that down into horizontal and vertical components. So A equals the magnitude of A cosine theta, that's my horizontal component, times the magnitude of A sine theta, that's my vertical component. So I can write 20 cosine 108 and 20 sine 108. And I'm going to go ahead and turn those into decimals because I think it'll be useful for us to be able to visualize like how many pounds. So the horizontal part is negative 6.18 and the vertical part is 19.02. So most of this force is in that vertical direction. It's not really in the horizontal direction. But I could also write this as negative 6.18 plus I plus 19.02 J. So it's another way that I could write that. Both ways are okay. Now, if I asked you to find a unit vector that was the same direction as this, but instead of a force of 20 pounds, it only had a force of 1 pound, let's see what that would look like. So for the unit vector, I'm going to take a, and I'm going to divide it by the magnitude of a. So I'm going to take negative 6.18, comma 19.02, and I'm going to divide it by 20. And so when I do that, negative 6.18 divided by 20, I will get negative 0.309. And when I do the vertical component divided by 20, I'll get 0.951. And so the way this would look on the diagram, and I'll choose a different color, not pink. Let's choose this green color, okay? So a unit vector on this diagram would be like a tiny little vector down here. It's in the same direction, but instead of having a length of 20, it has a length of 1, okay? And the reason why unit vectors are important is they can help minimize calculations because you focus all on the direction piece and then you layer back in like how long is that vector or what's the actual magnitude of that vector. All right, so folks, this is where we're going to finish for 7.3. If you have any questions, shoot me an email or send me a message on Canvas, and I'm happy to help you out. Thanks so much. Bye.